All right, good afternoon, everyone. I'm very excited to be here to talk to you, everyone, today about who we are, what we do, and what we think about the future of lab automation. HighRes, that's our new name, used to be HighRes BOS Solution. I just rebranded. We're right in front. Please stop by and come see us. Our new tagline, accelerating science, advancing humanity. Our mission is still the same. We accelerate the rate at which life science organizations impact human health. That's what we do. How we do it and how we're going to go about it in the future is going to be a little bit different. Not too different, but I think there's some important points in this next sentence that talk about what the future is going to be like. And I think some of the highlights in here, and we partner with life science organizations to implement intelligent data and lab automation. Intelligent being a primary differential, right? It's not just lab automation anymore. To hit, 4 nines of reliability in autonomous labs, you need strong, reliable, repeatable foundations, which are going to be built on intelligent automation, leveraging perception and physical AI. And we want to build tools that empower every team member. This is going to be the other major theme that I talk about. Automation can be complex. How do we make that problem much simpler? How do we make these complex tools accessible to the scientists or the ones who actually need to use these tools? And so we deliver these tools to every team member to execute efficient and reproducible science is what we do. I'm going to talk a little bit about our journey and what we're doing from a product perspective. Right now, when I look at lab automation, it hits a very limited amount of labs in the world from a scientist perspective. There gets to be a point in terms of complexity that it breaks down. Scientists, you maybe use it once or twice. If there's a problem, they put the tools and technology down. I think it's time from a products we've developed perspective and technology that we can bring these very advanced automation tools directly into the hands of scientists. And we've been building for this day for 20 years, really in the form of how do we make the most robust, resilient products? How do we do the most comprehensive APIs, right? And how do we leverage some of the new innovative technologies available into those areas? And I think this is where it gets really exciting. In terms of accessibility, there's a learning curve. There's so many things in how to program, to understand. Leveraging great technologies like AI and ML with the right knowledge sets makes that much more accessible and understandable and approachable. And then leveraging smart physical AI and perception ensures the robots run continuously, right? These are the challenges that we encounter all the time in the lab. So we're going to leverage and embrace innovation to really drive the accessibility and reliability of lab automation, which I think is the path to getting into the hands of every scientist out there. When we think about the lab today, there are challenges with it. You think about, I have a new experiment to run. How challenging it is to go from planning, from science to concept to translation into execution. There's different groups that understand different pieces. There's resources you have to map from place A to place B. It's not just the planning, it's the execution. Multiple teams, multiple experts on different products. How do you get this device to work? How do you do that? Why can't we bring all this together? And ultimately, all of this work is dependent on the analysis to have contextualized, rich data information automatically captured, ready to be consumed and processed. So we can have a nice, smart, closed loop. These are some of the pain areas that we see in the lab today. And this is how we think about changing the space. I want to talk a little bit about what we think the new future intelligent lab is comprised of. And I think about it in really these 4 key areas. I think for our customers, we want them to be autonomous, independent, enabled, empowered. Science changes quickly and they need to be able to as well. How do we support our customers to do that? What do our products need to have to enable those kind of situations? I put it into really 4 primary buckets. One is the accessible deployment. Science changes, you need to change, you need to evolve. We already have highly flexible hardware. Programming can be really hard. So why don't we make the design easy? You can do design yourself with our full 3D digital twin, model your whole space that will drive configuration in the software. Again, empower and enable you to do the complicated things. Leverage smart robots, intelligent automation, perception. Our robots can see. That means they can teach themselves. That's a complicated procedure. Remove the friction to using automation. And also use that perception to ensure we can identify and work around any error situations. We want it to be seamless. Open APIs on everything. HighRes has always been an API-first, API-forward company. We will continue to do that. And I think this has put us in a really good position for this next wave of innovation. To enable scientists in this space, we have to simplify the operations and the access. One, there's a lot of procedures scientists have to do to get a successful, repeatable result. A lot of details matter when you try to get repeatable science. There's so many ways and so many permutations and so many specific configurations that you have to get just right to get the repeatable result. So it's not just the program that runs a liquid handler, it's the whole process, the whole procedure. So by digitizing SOPs and putting them in the context of workflows, we're ensuring that repeatability. Simplifying the operation, a user can see in context how to follow all these steps. Not only that, take the complex software interfaces of today and make them more natural language. How do we do that in a way that connects at the level a scientist needs to understand and takes the complexities of our software and puts it into an accessible fashion? I'll show you a demo of this in a little bit. And obviously, as you have this lab and this equipment, you need to know what's going on. How do we create a single pane of glass to see your entire science surface, right? Coming into a single place, which ties us into the unified operations for executing science, global instrument control, whether on automated system or on benchtop. A single place where you can see, manage, track, and execute all of your instruments in a single cohesive fashion. Lots of these softwares on different devices are very complicated. Each one requires unique training. How do we make that much easier? How do we make it about the science and not about the complexity of the product? Part of this also is our digital twin. As a scientist works in this space, it's a very complex space. How do you inform them what to work on? I don't think there's a better way than to have a visual representation of the world they live in and to say, here's what you should look at. And it looks like just what they're looking at. I think it's the simplest way to communicate the intention of the world and see what the state of the world is. It matches. You don't have to translate. I think the more we can remove that translation barrier of understanding to knowing what it is, the more they can focus on science. And obviously a lot of this is built and depends on the automated data capture. For every bit of data you produce in your lab, track and channel through the same conduit, accessible from a single integration point with the full context of execution. This is what we need to feed into AI models to have the intelligence to build predictable scientific models. And last but not least, we need the automation to connect these individual components of the lab, whether it's intelligent mobile robots, modular platforms that we can easily interchange, right, to support evolution, and bringing in things like benchtop accessibility, benchtop solutions. So really spanning the whole range from manual procedures to bench side to completely automated, autonomous, integrated factories. When I think about our stack of the future and what I think the scientific lab of the future looks like, for us, it's really built on what's on the right, the foundational pieces. Okay, and I think it's similar to what we see in the world of compute. So Solario Scheduler for us is the engine or the operating system that makes this machine run efficiently, flawlessly, reliably, robustly, right? And so we'll have those in the edge. Why in the edge? We can't afford any network latency, downtimes. It's important, must always operate. We need to feed it with sufficient information. We'll couple that with our intelligent automation, things that can handle unplanned errors. The world is dynamic. The lab is dynamic. Things move. Automation needs to be more intelligent. That's our core execution layer. Let's go up a step. HighRes has been doing this for 20 years. The world of integration is a very, very, very challenging world. I wish it wasn't so challenging. My life would be a lot easier, but the reality it is. There's so many different devices, capabilities, standards. Something doesn't work. How do you get it to work? And we've built in practice a business that ensures we deliver success in complex integrations over this period. How do we take and package up what we do on a regular basis, our knowledge, our processes, our procedures, and embed that into our tooling? How do we give the intelligence that we have and put that into our software? And so we've built a product called Atlas, a culmination of 20 years of our experience, our deep knowledge of every single instrument out there, how it works, curated specifications, applications note, when should you use this dispenser? When this error occurs, here's how to recover it. It's the perfect user manual, the guide, the ultimate guide for anyone running a lab that we've now unleashed and given to our tooling. And how does all of this surface to the user? We've got three main ways. We've got our graphical interface, right? Solario OS, where you can design workflows digitally, like a workflow. I think it's the comfortable entry point. It's what people know, right? I think it's going to be the most common way to do it. We created a digital twin. Let's render the whole space in a way that's intuitive. Make it look like the lab. Let's surface the relevant information in that context. What's my incubator temperature? Where's my data? What's the state of the world? How do we quickly assess the lay of the land? And last but not least, modern interfaces like AI assistance and agentic capabilities in the lab. These are going to be the ways that we get to that 4 nines of repeatability for autonomous labs. I believe it's about the foundation and the fundamentals of automation that let us achieve that. I know we're doing some really advanced things on the science side, but unless we've got bulletproof foundations, I think it's going to fall short. And that's really where our focus is. How do we create the most productive, reliable context in which to operate a lab? I want to talk through a quick use case. So we've got in our booth a handful of new things to show and talk about. This is one of the most exciting ones. So in the world of Solario OS and in the lab, there are workflows. This is a workflow that is guiding a user across controlling or working with 3 benchtop instruments, right? PCR, it's a pretty straightforward example. We are working with an Opentron to perform a still dilution. We'll be doing a master mix dispense with a precise drop 2, and then we'll do a qPCR read in the Q tower. Okay, I'm sure many of you have done this on the bench. How do we make this really slick and really easy? We're going to show you here through Solario Lab Assistant. You simply speak the intent of the action you want to perform, the context of the science. I want to run qPCR. I want to do it with this dose response. I want to do it with this curve. Here's the master mix I want to add. Great. You can even be shorter than this, and we'll ask questions. We'll take that information, we'll analyze it, we'll understand the instruments you have in your space, we'll automatically design and develop a workflow, which can then be instantaneously executed. That's workflow gen. We have the same capability in Solario protocols. Going to the next step. So we've made the workflow. Let's execute it. How simple is this? Let's ask some questions. Here's the workflow we just created. Start the process. We hold your hand through every step. Step 1, pre-check. Load your reagents, load your materials. Are your devices ready? Great. We now control the instrument. We know the context. We drive it. We collect the data. This happens in a single place, seamless across any type of operation you have in your lab, whether it's a standalone device or a full system. What's the next step after this? Great. The data. As I mentioned, everything in our world captured and contextualized, right? In a single place. And with the same tooling, we can just talk about it. Did you capture data with that run? Sure did. Great. What's it look like? I don't know. How do you want to analyze it? Let's describe how we want to analyze it. What's the plate layout? Here's the concentration calculation I want to perform. Perfect. Give me a heat map. Great. Here's what your plate looks like. So within minutes, a pretty entry-level user can dream of the science they want to run and execute it with high confidence and high conviction. And this is just but a small snippet of the new capabilities we're watching here at SLAS and what we think is really the future of what lab automation and science is going to be. Thank you.